Okay, very good morning, my dear students. Today we can complete the properties of mutual information. Okay, and then we can solve some of the important problems regarding these different kinds of entropies and the mutual information. Okay, these problems are very important for your examination, and you will get almost all same model problems in your final exams. Okay, regarding this module. Actually, I did not dump the problems in the PPT. So I will provide you the Word document. You can check that Word document. So directly I will mention you the example number in your PPT and go through the corresponding example in the Word document. Okay. So all these things we have completed. First we have defined the marginal entropies. Next joint entropy. Conditional two different kinds of conditional entropies in terms of see already these equations you are very much thorough, I know that. Here you can observe but these are first two are the marginal entropies of transmitter and receiver section, and these two are represented in terms of the corresponding probability matrices. At a h of x aithe p of xj, that is the probability of the corresponding entropy, and p of yk is the probability of receiver section whose entropy is h of y. Already I told you matrix size of p of xj is m by 1, capital M by 1, and y matrix size is 1 by n. Okay, and the same I mentioned here, k is equal to 1 to n. So, but our P of x is, because at the transmitter we are using series to parallel converter, so it will be a m by 1. It has only one column and multiple rows. And for the receiver matrix, it has one row and multiple columns. So that the product of these two, P of xj into P of yk, if the matrices are independent, if the transmitter and receiver are independent, then the P of xj comma yk will be P of xj into P of yk. Based on the joint probability matrix P of xj comma yk, we can define the joint entropy h of xy. How? P of xj comma yk log P of xj comma yk base 2. And thus j ranges from 1 to n and k ranges from 1 to n. And also we define two different kinds of conditional entropies. Those entropies you can calculate by using the joint probability matrix and the corresponding conditional probability matrix. Okay, two matrices you need. And also we proved two relations between all the three different kinds of entropies. The joint entropy h of xy or h of x comma y, no matter whatever you represent, h of xy is equal to h of x plus y plus h of y. And it is also equal to h of y by x plus h of x. Okay, remember these expressions. This is h of x by y plus h of y, and this is h of y by x plus h of x, where h of x, h of y are the marginal entropies. H of x by y and h of y by x are the conditional entropies, and h of xy is the joint entropy. Okay, and we have proved the corresponding relations just by considering the LHS and using Bayes' theorem inside the logarithm function. We'll replace P of xj comma yk, and we solved. Directly we obtained. Just two relations you should know, that is summation j is equal to 1 to m P of xj comma yk is yk, P of yk. Okay, alade k is equal to 1 to n P of xj comma yk is P of xj. And if you know the Bayes' theorem, you can easily solve. And similarly, other relation also we took LHS and we have written the expression for joint entropy. And inside the logarithm, we used Bayes' theorem and we replaced based on the RHS. Because RHS lo h of y by x plus h of x unte, you will make use of P of xj comma yk as P of xj into P of yk by xj and replace chestar. For example, if you have RHS as h of x by y plus h of y, allow that code. Appudu we'll replace P of xj comma yk as P of yk into P of xj by yk. Okay, based on the corresponding RHS, we'll accordingly replace the P of xj comma yk present inside the logarithm. ఎందుకు అదే రీప్లేస్ చేస్తారు? బికాస్ లాగ్ a into b, you can replace it as log a plus log b. అంటే ఇక్కడ మనం స్ప్లిట్ చేయాలి కదా, సో దట్స్ వై we will use logarithm function only. సో ఇక్కడ రీప్లేస్ చేయకూడదు, inside the logarithm function. So joint probability matrix inside the logarithm you should replace, because ఇక్కడ మీరు summation కదా replace చేయాలి. So product you can convert it to summation by using logarithm function. Okay, and ఇక్కడ as usual direct expression వస్తుంది h of y by x, and h of p of x కింద replace చేయాలి. So summation k is equal to 1 to n p of xj comma yk we replaced as p of xj. Okay, so next already the last class only we defined the mutual information. How can you define the mutual information? It is defined as the difference between the two uncertainties due to p of xj and p of xj by yk. Okay, so I of xj comma yk is defined as I of xj minus I of xj by yk. So in other sense, if the receiver data is acknowledgement is sent back to the transmitter, the mutual information there is I of yk comma xj. That is I of yk minus I of yk by xj. Okay, so I of yk comma xj is I of yk minus I of yk by xj. So whatever may be from transmitter or to receiver, or the acknowledgement that is from receiver to transmitter, mutual information is defined as the difference between the two uncertainties due to the corresponding priori probability and posteriori probability knowing the information of the other side. అంటే ఇప్పుడు మీరు ట్రాన్స్మిటర్ చూస్తారు అంటే yk ఇన్ఫర్మేషన్ తెలియాలి, అదే రిసీవర్ అంటే I of yk comma xj స్పీక్ if you are speaking like that, then you should know the information of transmitter అంటే I of xj. Okay, where the information of the xj event is minus log p of xj base 2 or log 1 by p of xj base 2. The same fashion I of xj by yk, that is the posteriori probability of the transmitter knowing the receiver information. So I of xj by yk it's equal to log p of xj by yk base 2. Now please substitute the values of uncertainties or the informations from equation 2 in equation 1. So if you do like that, you will get I of xj comma yk as minus log p of xj base 2. Okay, so minus of minus that will be plus log p of xj by yk base 2. Okay, so I request the students to kindly mute your mic. 24, lateral entry 24. Okay, so I of xj comma yk is minus log p of xj base 2 plus log p of xj base 2. It is minus of minus kadama, so it will be plus here you will get. So that is log b by a. So log b by a you can represent. That is log p of xj by yk divided by p of xj. So this is the expression for mutual information of the transmitter. For example, if you want to get the mutual information of the receiver, it will be I of yk comma xj is log p of yk by xj whole divided by p of yk. Okay, that is the mutual information of the receiver section. Okay, but now let us go through the mutual properties. See, already I told you first 4 properties of mutual information. Just I will revise it for 10 minutes. So what is the first property of mutual information? It obeys symmetrical property. Here, instead of the average of mutual information, that is here capital I of xy is the average of mutual information. Okay, but I of xj by yk is the information of the transmitter due to uncertainties of priori and posteriori properties of transmitter section only. And I of yk comma xj is the mutual information of the receiver section, okay, having uncertainties due to its priori and posteriori probabilities. So it's said that our mutual information obeys symmetrical property. That is, I of xj comma yk is I of yk comma xj. So to solve this, every time you take the LHS. So LHS key, we have written the expression. What is the expression of I of xj comma yk? The last slide only we have derived. That is uncertainty due to its priori probability. Okay? I of xj minus uncertainty due to posteriori probability. That is I of xj by yk. But I of xj is minus p of xj and I of xj by yk is minus p of xj by minus log p of xj by yk base 2. So using that we have written log b by a. So minus log a plus log b anochindi. So we have written it as log p of xj by yk by p of xj base 2. Now, so here you have in the numerator you have p of xj by yk. So our intention is in the numerator instead of p of xj by yk, you should get it as p of yk by xj divided by p of yk raval bikku. Indukani RHS is I of yk comma xj. The equation for that is log p of yk by xj divided by p of yk. That is the expression for yk comma xj. So it is mandatory to use Bayes theorem because Bayes theorem states the relation between the different kinds of marginal probabilities P of xj and P of yk, conditional probabilities P of xj by yk and P of yk by xj, and the joint probability, that is P of xj comma yk. Okay, so anyhow just we used P of xj by yk to replace in terms of joint probability. So here P of xj by yk is, here you can see first equation in the Bayes theorem. You can replace P of xj by yk as P of xj comma yk divided by P of yk and replace here. So we replaced this P of xj by yk as P of xj comma yk divided by P of yk. Just we replaced by using that equation, and once again P of xj comma yk is replaced in terms of P of yk by xj into P of xj. So alla replace cheste P of xj gets cancelled, and so finally you will get log P of yk by xj whole divided by P of yk. So that you can replace it as minus log P of yk base 2, because so if you consider log P by a, so minus log a plus log b anustundi. So minus log P of yk base 2 plus log P of yk by xj base 2. So ikkada plus the minus of minus kinda raskunte. So minus log P of yk base 2 is the information of the receiver, that is I of yk. And minus log P of yk by xj, if you consider that that is the information or the uncertainty due to receiver yk knowing the information of xj. So I of yk by xj. So this is nothing but the RHS, if you observe, this is nothing but the information of the receiver event, okay, knowing the transmitter xjth event, or else it is defined as the mutual information which is due to of the receiver section, which is due to the difference of the uncertainties of priori probability and posteriori probability. The priori probability of receiver is I of yk and posteriori information of the receiver is I of yk by xj. The difference is the mutual information of the receiver section. So finally we can say that our mutual information obeys the symmetrical property. So second property is whenever yk is equal to xj, whenever yk is equal to xj, okay, so here you can say that okay, please wait 1 second. Okay. What is the second property? Whenever yk is equal to xj, that is corresponding events of receiver and transmitter are equal, then mutual information will act as a self-information అని చెప్తున్నారు. In order to prove this, directly take the expression of mutual information of either the transmitter or the receiver. Okay, transmitter తీసుకున్నాం ఇక్కడ మనం. So I of xj comma yk. This is equal to log p, general equation, that is log p of xj by yk divided by p of xj. So you can write it as minus log p of xj base 2 plus log p of xj by yk base 2. Okay, but here it is said that yk is equal to xj. So just replace yk is equal to xj. So xj gets cancelled. For the second time I am speaking. So log p of xj by yk. So that will be 0 because log 1 is 0. So when that's why we'll have only first term. First term is minus log p of xj base 2. That's the information or the uncertainty of transmitter. So xjth event. So I of xj replace చేసుకోవచ్చు. So that's why second term becomes 0 and first term is I of xj. So whenever yk is equal to xj or xj is equal to yk, mutual information will act as a self-information. Similarly, if yk is equal to xj, then I of yk comma xj will be I of yk అని వస్తుంది. Okay, whatever may be the mutual information, if it is for transmitter, you will get it as I of xj comma yk is I of xj. If it is for the receiver, కి ఎలా వస్తుందమ్మా? I of yk comma xj is I of yk. Next, average of mutual information, that is I of yk. So it is defined as, so average of mutual information is represented as capital I of xy, which is the average of all the elements present in I of xj comma yk. So that's why we took bar, I of xj comma yk whole bar. Bar represents the average. So అన్ని elements కాబట్టి it is defined as summation j is equal to 1 to m, summation k is equal to 1 to n. Consider all the elements with the joint probability matrix. So p of xj comma yk into the individual elements mutual information, that is I of xj comma yk. Okay, just you from the definition of I of xj comma yk, replace it as log p of xj by yk divided by p of xj. Okay, now so please replace summation ఇక్కడ మనకి like here if you observe summation k is equal to 1 to n p of xj comma yk, we can define it as p of xj. So minus summation j is equal to 1 to n 1 to m p of xj log p of xj base 2. It is nothing but the entropy of the transmitter, that is h of x. Similarly, if you observe, if you replace this plus as minus of minus, so minus summation j is equal to 1 to m summation k is equal to 1 to n p of xj comma yk log p of xj by yk base 2. This is the definition for h of x by y. So conditional entropy. So just I represented like this. So this is the third property. So average of mutual information capital I of xy, which is stated as average of all the elements of I of xj comma yk. So summation j is equal to 1 to m, summation k is equal to 1 to n, p of xj comma yk into I of xj comma yk. So finally we obtain the average of mutual information capital I of xy as h of x minus h of x by y. But already from the like a relation between all the entropies, you know, h of xy is h of y by x plus h of x or h of x by y plus h of y. So using those two relations, replace here h of y by x. Here we have h of x by y. Please replace that. Here already we know the relation shown in the equation 2, and equation 1 is the relation between the average of mutual information h of x and h of x by y. That's what we obtained in the third property. So using the equations 2 already proved, we can replace h of x by y here. From the first relation, h of x by y is h of xy minus h of y. Upon substituting, you will get equation 4. What is that equation 4? I of xy is h of x plus h of y minus h of xy. So whenever in the exams, if you want to prove the fourth relation, that is I of xy is equal to h of x plus h of y minus h of xy. So in order to prove this, you should state the third property of mutual information. So ఏంటది average of mutual information definition start చేసి అక్కడి నుంచి ఇక్కడ వరకు ప్రూవ్ చేయాలి అంటే so I will show you almost all from this point. ikkadi నుంచి average of mutual information I of xy, start from this, first you prove this and then you go to you can directly represent the relations between the entropy. So if you want to prove I of xy as h of x plus h of y minus h of xy, so second relations ni prove cheyalsina avasaram ledu, but you should start from third property. Okay, so once we have this relation, once again represent h of xy in terms of h of y by x. Okay, already you know h of xy is h of x plus h of y by x. So just I replace this and finally you will obtain I of xy also as h of y minus h of y by x. So if you want to prove the 3, 4, 5 relations, if you want to prove 3, 4, 5 relations, you should start from the third property of mutual information. Akkadi nunchi start chesi and if first and two relations prove cheyalsina avasaram ledhu akkada. So directly you can solve for I of xy in terms of h of x, h of y, h of xy, h of x by y, and h of y by x. For example, if you want to prove first and two relations, take LHS, write down the expression for joint entropy, replace in terms of Bayes theorem so that you can prove first and second relations. Okay. Now fourth property of mutual information. So what is the fourth property? For a noise-free channel, output is equal to input. Already you know, if the channel is noise-free, output matches directly to the input without any disturbance or distortion or any like amplitude change. Mutual information I of xy is equal to h of x, which is equal to h of y. Okay, so you can observe the noise-free channel here. Here output is equal to input. So x1. So here, for example, if there are m number of events on the transmitter side and same number of events on the receiver side, and let the events of transmitter be x1, x2 up to so on xn, and the events of receiver be y1, y2, y3 up to so on ym. These are if you can observe the channel shown here. Because there is no distortion or no kind of interference or any kind of amplitude variations here, directly due to the event x1, the output should be y1 only. And because of x2, output should be y2. And because of xm, output should be ym. So what is the probability matrix P of xy? This is a joint probability matrix. Okay, here x1, so whenever the input is x1, the output is only y1. So only x1, y1 event will occur, and x1, y2 magnitude is 0 because we said that there is no noise. So directly the transmitter event goes to the receiver section. So x2 will be y2. So only the events x1, y1, x2, y2 up to so on xm, ym will exist. Okay. So it will be first. So if you see the joint probability matrix, first element is x1, y1, so it exists. Next x1, y2, it won't exist because there is no path here. x1, y3 don't exist. Alane xm, ym also don't exist. So anni kuda all the elements in the first row are 0 except x1, y1. Similarly, if you observe the second row, x1, y2 is 0. Okay, and x2, y2 will exist, and similarly x2 y3 is 0 up to so on, x2 ym is also 0. And if you extend the same up to the last row, okay, where xm ym will only exist, xm y1 won't exist, x1 y2 won't exist, and up to so on, xm ym will only exist. So if you clearly or carefully observe the matrix, that is joint probability matrix, capital P of xy, you can say that for a noise free channel, it should be the diagonal matrix. First term thing is it should be diagonal matrix. But here in the first row, if you observe, first row observe cheste మనకి ఏంటి sum of all the elements in the first row should be equal to 1 అంటే P of x. So అలానే second row should also be 1, third row should also be 1. అలానే sum of all the elements in the first column should be equal to 1 అంటే x1 y1 plus 0 plus 0 0 అంటే 1 1. అలానే second column element 0 should be 1. So okay, then x1 y1 should be, x2 y2 should be, x2 xm ym should be, all should be equal to 1. ఎందుకని what is the maximum probability? 1. So in the first row, if you observe, x1 y1 plus 0 plus 0 plus 0 all should be equal to 1. So x1 y1 should be equal to 1. So that's why this then you will get P of x by y or P of y by x, because in the case of P of x by y, sum of all the column elements should be equal to 1. అంటే మీరు ఇప్పుడు ఫస్ట్ కాలమ్ తీసుకుంటే 8 ఎలిమెంట్స్ x1 y1 plus 0 plus 0 plus 0 అంటే should be 1 అంటే x1 y1 should be equal to 1. సో అలానే సెకండ్ కాలమ్ x2 y2 1 అవ్వాలి కండిషన్. అండ్ ఇఫ్ యూ అబ్జర్వ్ P of y by x matrix, all the elements of a row should be equal to 1. All elements present in each row should be equal to 1. So అందుకని based on this condition of either P of x by y or P of y by x, x1 y1 should be equal to x2 y2 should be equal to, all should be equal to 1. So that's why we have represented it as the unity diagonal matrix. What is the matrix size? M by M, because here we have M rows and M elements of the transmitter and M events of the receiver. Now, from the second property of entropy, already we discussed this. What is the second property? Even though we have M number of events or M number of occurrences, for example, if any one of the probability of event is maximum, that is equal to 1, and if all others are 0, so if you consider any row or any column, only one element or one event has maximum probability equal to 1 and all others are 0, then the corresponding entropy is 0. ఎందుకని 1 log 1 plus 0 log 0 plus up to so on 0 log 0. So 1 log 1 is 0 and 0 log 0 is also 0. Okay, so that's why h of x by y or h of y by x is 0. Now actually what you need to calculate for a noise free channel, we are going to define the mutual information. So mutual information I of xy is h of x minus h of x by y, or you can also define it as h of y minus h of y by x. But h of x by y and h of y by x both are 0 for the noise free channel. So for the noise free channel, if you replace h of x by y and h of y by x as 0, I of xy will be h of x and it is also equal to h of y. This is the fourth property. So you need to prove this, show the proof also. For a noise free channel anagane, you should draw this channel and you should mention the joint probability matrix first and then define the conditional probability matrices. Based on the conditional probability matrix, define the entropies. Okay, so from the definition of mutual information, I of xy is either h of x minus y or h of y minus h of y by x. So upon replacing the two conditional entropies as 0, I of xy will be h of x and it is also equal to h of y. Okay, this is the fourth property. Now, let us move to the fifth property. In the fifth property, I said you mutual information for an independent channel is 0. mutual information for an independent channel is 0. For independent channel, what is the condition? If we want to say that the channel is independent, the joint independent అంటే transmitter కి receiver కి అసలు relation లేదు అని చెప్తున్నట్టు. There is no dependency of a receiver on transmitter or transmitter on receiver. In the independent channel, what is the condition? Joint probability is equal to the product of individual probabilities of transmitter and receiver. Because this is the basic thing that you should know. For an independent event or independent channel, the joint probability should be equal to the product of individual probabilities. So ఇక్కడ individual probabilities అంటే ఏంటంటే general గా P of xj and P of yk. Okay, so what is the condition for independent channel? This equation is based on the one of the property of independent channel events. I think you have studied in probability theory and stochastics. So in independent channel, joint probability is equal to the product of individual probabilities of transmitter and receiver. So we can represent P of xj comma yk as P of xj into P of yk. Okay, and second condition is, this is the first condition, and second condition of independent channel is either all row elements or all column elements are equal. Row elements or column elements are equal. This is the second condition. So first row, if you consider, the elements are 2, 3, 1. And the second row element should be either 3, 1, 2 or 2, 3, 1 or 1, 3, 2. But elements should be same. And third row should be 1, 3, 2. Whatever may be the position of the corresponding element in the row, but row 1 elements equals to row 2 elements, third row, fourth row, all the elements should be equal. Whatever may be the position of each element. So alane column elements, either all row elements or column elements, any one of them can be equal. And the first column elements equals to second column or third column, fourth column. So all the column elements are equal, or all the row elements are equal. These two are the conditions for independent channel. Okay, for an independent channel, we are going to calculate the mutual information. So in an independent channel, the joint probability is equal to the product of individual probabilities of transmitter and receiver. So I have mentioned it red color. P of xj comma yk is P of xj into P of yk. And the second condition is all row elements or all column elements are equal. So either row elements or all column elements are equal. Now, from the Bayes theorem, once again, let us recollect. So joint probability matrix P of xj comma yk is equal to P of yk into P of xj by yk, or P of xj into P of yk by xj. So make use of this Bayes theorem and let us relate conditional probability matrices with individual marginal probabilities, because here the equation of joint probability with respect to marginal and marginal probabilities ఇక్కడ relation వచ్చింది మనకి. Now using Bayes theorem, let us relate the conditional probabilities with marginal probabilities. Okay, what is P of xj comma yk for independent channel? It is P of xj into P of yk. Just equate that to first term of Bayes theorem and the second term of Bayes theorem. First term, what is the first term? P of yk into P of xj by yk. First term is P of yk into P of xj by yk. And the second term is P of xj into P of yk by xj. So just I substituted and equated to P of xj into P of yk. Okay, so P of xj into P of yk, it is equal to first term. 8 the first term P of yk into P of xj by yk, or P of xj by yk into P of yk. Okay, and P of xj into P of yk is equal to P of yk by xj into P of xj. Here P of xj gets cancelled and P of yk gets cancelled. So for an independent channel, we obtained P of xj by yk as P of xj and P of yk by xj as P of yk. This is only for the independent channel. Okay. Now, from the definition of mutual information, already you know the definition of average of mutual information. See, whenever I represent capital I of xy, that's not the mutual information of particular event. It is the average of mutual information. So, from the third property, we obtained h of x minus h of x by y, or h of y minus h of y by x. Okay, so I of xy, you can write it as, using the third property, h of x minus h of x by y, or h of y minus h of y by x. So remember this equation. Let us move to the next slide. So already you know the definition of conditional entropy. What is the definition of conditional entropy? H of x by y is equal to minus summation j is equal to 1 to n, summation k is equal to 1 to n, P of xj comma yk into log P of xj by yk base 2. Okay, this is the definition of conditional entropy. I considered first h of x by y. Okay, because I of x by is h of x minus h of y. So that relation is sufficient. No need to prove h of y by x also for this property. Okay, so what is the condition for independent channel joint probability? So, but for an independent channel, joint probability is equal to product of individual probabilities of transmitter and receiver. That is P of xj comma yk is equal to P product under kabatti P of xj into yk. So ఇప్పుడు మీరు ఏం చేస్తారంటే please replace x of xj comma yk as P of xj into P of yk. Please replace. So please replace P of xj comma yk as P of xj into P of yk. Okay, that you can see from the next point. So therefore h of x by y is minus summation j is equal to 1 to n, summation k is equal to 1 to n. P of xj comma yk ఏం చెప్తున్నారు? P of xj into P of yk. Please substitute that into log P of xj by yk base 2 into log, as usual ఉంటుంది. The second term will be as usual, but P of xj comma yk is replaced as P of xj into P of yk. That's all. Now here, so please observe. So here summation k is equal to 1 to n, P of xj comma yk is P of xj. Okay, but what is P of xj? Summation k is equal to 1 to n, P of xj comma yk. You can replace, okay, please substitute. Then you can get h of xy as minus summation j is equal to 1 to n, 1 to m, because k is equal to 1 to m. You are representing P of xj into log P of xj, log P of xj by yk base 2. Okay, but from the equation 1, what is equation 1? You can, I will once again go back. From the equation 1, what you obtained? P of xj by yk as P of xj. Okay. Here you can replace P of xj by yk as P of xj. Okay. So if you replace, then h of x by y will be minus summation j is equal to 1 to m. Okay. P of xj. ఇక్కడ m అమ్మా ఇక్కడ. Okay. So this is m. Okay. Please wait. The same one. Okay. So here we can obtain if you replace P of xj by yk. If you replace P of xj by yk as P of xj, this is from the equation 1, then you will get minus summation j is equal to 1 to m P of xj log P of xj by yk. So replace this log function inside the logarithm. Replace the probability matrix inside the logarithm as P of xj. Then you will get minus summation j is equal to 1 to m P of xj log P of xj base 2. So that is nothing but h of x. So that's why from the definition of mutual information, I of xy is equal to h of x by either h of x minus h of x by y or h of y minus h of y by x. But here we are replacing in terms of h of x by y in terms of h of x. So h of x minus h of x by y. So that will be equal to h of x minus h of x, that is 0. So for an independent channel, what is the mutual information? For the independent channel, you can see that for an independent channel, mutual information is 0. So what are the five properties that we have discussed? Mutual information is symmetric in property. So I of x by xj comma yk is I of yk comma xj. And second property, what is the second property? Let us go through the second property. What is the second property? Just we have defined the mutual information will act as a self information when yk is equal to xj. A third information, we have defined the average of mutual information as h of x minus h of x by y, or h of y minus h of y by x, or h of x plus h of y minus h of x by. And similarly, we have defined the fourth property as for a noise free channel, mutual information I of xy is h of x or h of y. Because for a noise free channel, conditional entropies are 0. H of x by y or h of y by x is 0. And mutual information for an independent channel is 0 because joint probability is equal to product of individual probabilities, and all row elements or column elements are 0. Using Bayes theorem, we obtained P of xj by yk as P of xj. And we used, we substituted we took the equation of h of xy and we obtained it as h of x by replacing P of xj comma yk as P of xj and from the equation 1, and summation k is equal to 1 to n P of xj comma yk, you can write it as P of xj. So you will get it as minus summation j is equal to 1 to m P of xj log P of xj base 2. This is nothing but h of x. Okay. So actually there is no need of representing this equation here. Okay, this third equation represents అవసరం లేదు. Directly you can replace summation k is equal to 1 to n P of xj comma yk as P of xj. Okay, then you will get h of x by y as h of x. Therefore, I of xy will be 0. So mutual information for an independent channel is 0. Now, I think with this we have completed the first portion of unit 4. Because we discussed the information and its properties, entropies and its properties, and similarly different kinds of entropies we discussed, and also information rate and several problems we have discussed. And now we discussed in this module, we discussed different kinds of entropies and mutual information. Okay, but till now we have not gone through the model of problems that you will get from module 4. That is mutual information, marginal, joint and conditional entropies, relations. Okay, so we can go through the problems, the separate Word document. You can check fourth and fifth examples. So every time I will mention like this from now onwards for this fourth unit. Okay, so this is the document which I will provide you. So Word document, fourth and fifth examples, you can see, you will get the same model. Okay, so this is the fourth example, which you can see here. See here, you can observe that this problem is based on mutual information, marginal entropies, joint and conditional entropies. Okay, now, so you will get this kind of problems. Please listen carefully. Okay, I request any one of you to please tell me, is it clearly visible to you, or I have to improve his font? Is it okay? One of you please respond. Is this font okay to you?
Yes, ma'am.
Okay, thank you. Okay, please listen carefully. So here, a discrete source transmits messages. So how many messages like input events are there or input messages are there from transmitter? X1, X2, X3. The three messages they transmit చేస్తుంది. With probabilities P of X1 which is equal to 0.3. So P of X1 is 0.3. P of X2 is 0.25. P of X3 is 0.45. So three messages are there with probabilities P of capital X. So ఇక్కడ మీరు P ని ఎలా రాసుకోవాలి ఇప్పుడు? P of capital X will be the joint like marginal probability of the transmitter. So how many elements are there or how many messages are there? 3. X1, X2, X3. మనం యాక్చువల్గా ఇక్కడ ఈవెంట్స్ అని చదువుకున్నాం. Here the events are the messages. Now, can any one of you tell me what is the matrix size of P of capital X? ఎవరైనా చెప్తారమ్మా? What is the matrix size of P of X? What is the matrix size of P of X? Any one of you, please speak. So these model of problems are very, very, very important. So ఖచ్చితంగా ఈ మోడల్ నుంచి వస్తాయి మీకు ప్రాబ్లమ్స్. How many elements are there at least in the transmitter? అది చెప్పండి పోనీ at least size తర్వాత చెప్పొచ్చు. Twenty-seven members are there. So any one of you please respond. What is the matrix size of P of X? or at least ఎన్ని మెసేజెస్ ఉన్నాయమ్మా? How many messages are there? How many messages are there? Please, any one of you respond. Laterality 22. Ma, laterality 22. Are you there? M3. M3.
Ma'am?
Okay. Okay, here you can see the 3 elements of transmitter are given. So
Yes,
P of
ma'am.
x1 that is 0.3, P of x2 that is 0.25 and P of x3 0.45 each are. Can
Yes,
you
ma'am.
tell me what is the matrix size of P of x?
3 by 1, ma'am.
Yes, it's 3 by 1. Okay, but generally represent చేసేటప్పుడు మామూలుగా 0.3, 0.25, 0.45 అని మెన్షన్ చేస్తారు. But it is a matrix of 3 by 1. Okay, ma. Okay, thank you. You can mute. The source is connected to the channel whose conditional probability matrix is P of y by x. So మీకు ఏంటి ఇచ్చారు ఇక్కడ? Conditional probability matrix ఇచ్చారు. That is P of y by x, which is of size 3 by 3. It is of size 3 by 3. Here x1 represents the first row, x2 represents the second row and x3 represents the third row, and similarly y1 represents the first column, y2 represents second column and y3 represents the third column. Okay, so for these whole problems y1, y2, y3 represents the first column, second column and third column respectively. x1, x2, x3 represents the first row, second row, third row. Here this is a conditional probability matrix. It is given of size 3 by 3. Okay, and here it is given to calculate the different kinds of entropies and mutual information with this channel. So I think you know, calculate all the entropies అంటే ఏంటి ఉంటున్నాయి మనకి 5 kinds of entropies ఉన్నాయి. 2 are marginal entropies అంటే capital H of x or capital H of y, or marginal entropy that, okay, marginal entropy is H of x, H of y, conditional entropy H of xy, and sorry, joint entropy H of xy, and conditional entropies are H of x by y or H of y by x. So 5 kinds of entropies calculate cheyali, and using entropies you can solve the mutual information I of xy, because 3, 4, 5 relations gives you the interdependency of mutual information on the different entropies. Okay, so whenever a problem is given like this, first every time you remember that you should calculate the joint probability matrix P of xy using the conditional probability matrix. అదే మీకు డైరెక్ట్ గా p of xy ఇచ్చిస్తే there is no issue here. Okay, so if p of xy is directly given, what is p of xy? Joint probability matrix. So if it is given to you directly, there is no need one. First step, there is no need. Okay, but whenever either p of y by x or p of xy, x by y is given, then first step is to calculate the p of xy, that is joint probability matrix. But మనకి ఇక్కడ ఏంటి ఇచ్చారు? p of xy ఇవ్వలేదు, p of y by x is given and various elements of p of x are given. For example, in the question, if you are given with the p of x by y say, then the receiver messages, the question you will get receiver messages అంటే p of y1, p of y2, p of y3 అని చెప్పి ఇస్తారు. Okay, because p of y by x into p of x gives you p of x by y, or p of x by y into p of y gives you p of xy, because that is from the Bayes theorem. So from the Bayes theorem you can write p of xy as, చూడండి, p of y by x into p of x, or it is also equal to p of x by y into p of y. Okay, so whatever may be, here you are given with p of x and p of y by x. So make use of this relation, because this is from the Bayes theorem only. Okay, so to calculate the joint probability matrix. So for example, in the question, if it is given p of xy, there is no need of calculating the other thing. So direct ga use cheskoni you can start with step 2, start from step 2. Okay, so I think question is clear to you. Now what is the first step? First step is to calculate the joint probability matrix, and once you obtain the joint probability matrix, whether it is given or not, first step is to calculate p of xy, and second step is, if p of x1, p of x2, p of x3 are given, then calculate the receiver message probabilities. Or if receiver probabilities ఇస్తే మీకు calculate the transmitter probabilities. అంటే p of x1, x2, ఎన్ని మెసేజెస్ ఉంటాయి అన్నది that depends on matrix size once again. Here because it is 3 by 3, three transmitter messages and 3 receiver messages. Sometimes there may be 2 by 3 or 3 by 2 matrix will also be available. First you see the procedure. First thing is get the joint probability, and the second step is obtain the unknown probabilities already. Here unknown are p of y1, y2, y3. That is the second step. And what is the third step? Third rule is to calculate the conditional probability matrix. That may be p of x by y or p of y by x. Whatever is unknown to you, please calculate the unknown conditional probability matrix. Here p of y by x is given in the question, so you should calculate p of x by y. Okay, and next thing is obtain the marginal entropies. What are the marginal entropies? H of x and h of y. Because p of x and p of y, see p of x, capital P of x, ఇక్కడ రాసుకోండి, లేదంటే obtain the marginal entropies h of x and h of y using p of x and p of y. So where p of x consists of 3 elements: p of x1, p of x2, p of x3. P of y consists of p of y1, p of y2 and p of y3. And here p of y1 is a 1 by 3 matrix. Okay, so after calculating the marginal entropies, next calculate the conditional entropy. ఇప్పుడు మీరు conditional entropy calculate చేయాలి అంటే you should know the p of xy, that is joint probability matrix, and corresponding conditional probability matrix. What is the corresponding conditional probability matrix of conditional entropy h of x by y? That is p of x by y. ఆల్రెడీ ఇక్కడ మనం క్యాలిక్యులేట్ చేసాం కాబట్టి డైరెక్ట్లీ యూ కెన్ క్యాలిక్యులేట్. అదర్వైజ్ యూ ప్లీజ్ రైట్ హియర్ యూజింగ్ ఏ matrix is a joint probability matrix, that is P of x comma y and P of x by y. Okay, this is the fifth step. Next, calculate the joint entropy using only joint probability is sufficient. So, అందుకని ఇక్కడ మనం joint probability పెట్టేస్తే సరిపోతుంది. Next, calculate the mutual information because h of x, h of y and h of xy are calculated. So, using that you can calculate mutual information I of xy as, because there are three relations. I of xy can be defined as either h of x plus h of y minus h of xy or h of x minus h of x by y or h of y minus h of y by x. Okay, you can use any relation to calculate the mutual information I of xy. These are the steps that you should follow in order to calculate the different kinds of entropies and mutual information. So, what is the first step? Always you should know that joint probability matrix and individual marginal probabilities first. Okay, first let us calculate P of xy using Bayes theorem, P of y by x into P of x. So, let us move to the step 1. What is the first step? First step is to calculate the joint probability matrix P of xy. Please all of you write down this problem, because until and unless you write down in your notebook you can't be more clear. So నేను చెప్తూ వెళ్ళిపోతే that's not enough, because you need to practice. Please take your notebook and please write down. So theory okay, but the problems you should do on your own. Please write down. First step is obtain the joint probability matrix capital P of x comma y. Please write down. P of xy is the joint probability matrix which can be obtained as P of y by x into P of x or P of x by y into P of y. But from the question we have only P of y by x. ఇక్కడ మన క్వశ్చన్ లో ఏంటి ఇచ్చారు? Only P of y by x is given to you. So మనకి ఎలా వస్తుంది? P of xy, P of y by x into P of x. And P of x elements are 0.3, 0.25 and 0.45. So first step is to calculate the joint probability matrix P of xy. So P of xy is P of y by x, which is given in the question, P of x into P of x. So ఇప్పుడు మీరు P of y by x ఏంటమ్మా? 0.900. ఫస్ట్ రో ఎలిమెంట్స్ ఆర్ చూడండి సేమ్ మ్యాట్రిక్స్ తీసుకున్నాను. 0.9, 0.1, 0. నెక్స్ట్ 0, 0.8, 0.2, 0, 0.3, 0.7. అండ్ P of x ఏంటంటే ఇచ్చారు 0.3, 0.25, 0.45. Please observe that sum of all the elements of P of x should be equal to 1. Okay, and please remember one more condition to prove that it's the joint probability, conditional probability matrix key, like so to check, to cross check, if you want to check that it is the corresponding conditional probability matrix. అంటే ఇప్పుడు మీకు P of y by x అన్నారు అనుకోండి. So how can you say that it is P of y by x? If you observe the first row elements ఏంటమ్మా? x1 ఒకసారి చూసుకోండి 0.9 plus 0.1 plus 0. Sum of all the elements in x1 first row is 1. And similarly second row check చేసుకోండి 0 plus 0.8 plus 0.2, it is 1. Similarly, if you check x3, that is 0, 0.3, 0.7. Third row elements kuda sum entama 1. So that is the condition to cross verify that it's a conditional probability matrix. P of y by x. Denominator లో ఏంటుందో చూసుకోండి ఇక్కడ. వాట్ ఈస్ దేర్ ఇన్ డినామినేటర్ x. అంటే sum of elements in each row should be equal to 1. y1 అబ్జర్వ్ చేస్తే 0.9 plus 0 plus 0. Is it 1? No. Okay. So, but that is a condition for P of x by y. So, what is the condition for P of x by y? Denominator ఏంటుంటుందమ్మా? P of x by y. x by y అంటే డినామినేటర్ లో y ఉంది అంటే ఫస్ట్ కాలమ్ ఎలిమెంట్స్ అన్ని సమ్ తీసుకుంటే 1 రావాలి. ఇఫ్ యూ అబ్జర్వ్ సెకండ్ కాలమ్ ఎలిమెంట్స్ ఇట్ షుడ్ బి ఈక్వల్ టు 1. థర్డ్ కాలమ్ ఎలిమెంట్స్ షుడ్ బి ఈక్వల్ టు 1. And another condition to check that it is joint probability matrix, sum of all the elements in the whole matrix should be equal to 1. Adi condition. So conditions raskunnara. What is the condition to check it is P of x or P of y? So sum of all elements should be equal to 1, either in P of x or P of y. What is the condition to check it is P of y by x or P of x by y? So denominator lo ఏంటుందో చెక్ చేసుకోండి. If it is x, sum of all the elements in each row should be equal to 1. First row, second row, third row అన్ని 1 ఉండాలి. అదే P of x by y అన్నారు అనుకోండి, sum of elements in each column should be equal to 1. ఇక్కడ P of y by x కాబట్టి row లో ఉన్న ఎలిమెంట్స్ అన్ని సమ్ 1 అవ్వాలి. సో sum of the first row is also 1. Second row చూసుకున్నా, third row చూసుకున్నా sum of all the event probabilities is 1. And what is the condition to check its P of xy at a joint probability matrix? Sum of all the elements should be equal to 1. అంటే అన్ని rows అన్ని columns యాడ్ చేస్తే total elements sum తీసుకుంటే 1 రావాలి. That is the condition for P of xy. So if you know these rules, ఈ cross verification ఉంటే మీకు ఆన్సర్స్ తప్పు రాదు. So even if you get some different answer, you can say that your answer is wrong and you can once again verify it. Okay, so ఈ 3 conditions గుర్తుపెట్టుకోండి. Okay. Now, so here what is P of xy? You can observe P of xy as P of y by x into P of x. Please write down. రాసుకున్నారమ్మా? Obtain the joint probability matrix P of xy as P of y by x into P of x. So P of y by x ఏంటి? 0.900. You can write down the same matrix multiplied by P of x. What are the elements in P of x? I said you that is 3 by 1 matrix. It is 3 by 1 matrix. అంటే 3 rows 1 column ఉంటుంది. 3 rows and 1 column. అంటే 0.3, 0.25 and 0.45. Okay, P of x is first row element is 0.3, second row element is 0.25, third row element is 0.45. So please multiply the first row of P of y by x with 0.3 because the first row of P of x is 0.3. By ఇది కొంచెం జాగ్రత్తగా చూడాలి. What is P of y by x? Directly we took the matrix. And P of x is a matrix of size 3 by 1. అంటే 3 rows and only 1 column. In the 3 rows, first row element of P of x is multiplied by the first row of P of y by x. First row of P of y is 0.9, 0.1 and 0. So first row of P of y by x is multiplied by P of x. What is P of x first row? 0.3. So అందుకని first row is multiplied by 0.3. And second row of P of y by x is multiplied by second row of P of x. What is the second row element of P of x? 0.25. ఇది కొంచెం జాగ్రత్తగా వినాలి. P of y by x second row is multiplied by second row element of P of x. Second row element of P of x is 0.25. So 0, 0.8 into 2, 0.25, అలానే 0.2 into 0.25. Next, third row of P of y by x, third row of P of y by x is multiplied by P of x. Third row into వరకు 0.45. So third row మొత్తం third row element of P of x తో multiply చేస్తారు. So 0, 0.3 into 0.45, అలానే 0.7 into 0.45 వస్తుంది. నెక్స్ట్ సో ఇలా మల్టిప్లై చేస్తే 0.9 into 0.3 అంటే 0.27. నెక్స్ట్ 0.1 into 0.3 అంటే 0.03. అండ్ థర్డ్ ఎలిమెంట్ 0. నెక్స్ట్ సెకండ్ రో 0, 0.8 into 0.25, దట్ ఈస్ 0.2. Next 0.2 into 0.25, that is 0.05. Okay. Next third row 0. Next second element of third row, that is 0.3 into 0.45 అంటే మనకి 0.135 వస్తుంది. Next 0.7 into 0.45, that is 0.135. Now you got some joint probability matrix. ఏదో వచ్చింది మొత్తానికి. Now how can you say that your answer is correct? What is the condition to say, to prove that it's the obtained joint probability matrix is P of xy? Obtained matrix is P of xy, that is joint probability matrix. So I said you earlier, what is the condition to say that it is a joint probability matrix? Any one of you, can you please respond? But చెప్తారా, what is the condition to say that it's a joint probability matrix? So you got some answer by using Bayes' theorem. So any one of you, please tell me what is the condition to prove, to say that it is the joint probability matrix? So whenever one matrix is given to you, you should be able to tell that it is a joint probability matrix or conditional probability matrix. So ఇప్పుడు ఇది joint probability matrix వచ్చింది మనకి. How can you say that your answer is correct? So any one of you kindly respond. Please unmute yourself and tell me. M0, M0, M0.
Yes, ma'am.
But how can you say that the obtained answer is for joint probability matrix is correct? ఇప్పుడు ఈ ఆన్సర్ వచ్చింది, ఇది కరెక్ట్ అని ఎలా చెప్తారు? వాట్ ఈస్ ద కండిషన్? మాకు చెప్తారా? వినట్లేదా క్లాస్?
అంటే నోట్ చేసుకోలేదు.
మరి నోట్ చేసుకోమని చెప్తున్నారు కదబ్బా, ఆల్రెడీ నెమ్మదిగానే వెళ్తున్నాడు కదా సిలబస్. ఓకే, ప్లీజ్ మ్యూట్ యువర్ సెల్ఫ్. M2 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 M2, are you there?
Yes, ma'am.
Okay. Okay. What is the condition to cross verify your answer for a joint probability matrix? I think your section is good enough, but why you are not answering to our questions? బాగానే చదువుతారు కదా అందరూ. N4 చెప్పప్పా, can you say that your answer is correct for joint probability matrix is correct? What is the condition?
Sum of all the elements in matrix is unity.
ఓకే, అంటే మీరు రాసుకోవట్లేదు ఎవరు కూడా, మరి అదే చెప్పేది. ప్లీజ్ రైట్ డౌన్ వెన్ ఎవర్ స్టేట్మెంట్ ఈస్ గివెన్ టు యూ, ప్లీజ్ రైట్ డౌన్. సో మళ్ళీ మీకు ప్రతిసారి కండిషన్స్ చెప్పలేం కదా. వెన్ ఎవర్ క్లాస్ ఈస్ గోయింగ్ ఆన్, ప్లీజ్ రైట్ డౌన్ ద పాయింట్స్ వాట్ ద టీచర్ ఈస్ టెలింగ్ టు యూ. ఓకే, ప్లీజ్ మ్యూట్ యువర్ సెల్ఫ్. థ్యాంక్ యూ, గుడ్. సో ఇన్ ఆర్డర్ టు చెక్ దట్ కండిషన్ ఫర్ P of xy, here you can see the sum of all the elements in the matrix. అన్ని ఎలిమెంట్స్ మ్యాట్రిక్స్ సమ్ చేయండి. సో 0.27 ప్లస్ 0.03 దట్ ఈస్ 0.3 ప్లస్ 0 ప్లస్ 0 ప్లస్ 0.2 అంటే 0.5 వచ్చింది మనకి. ఆల్రెడీ ఫస్ట్ రోలో 0.3, ఇక్కడ 0.2 అంటే 0.5. నెక్స్ట్ 0.05 is 0.55 ప్లస్ 0 ప్లస్ 0.05 ప్లస్ 0.135 ప్లస్ 0.315 మొత్తం సమ్ చేస్తే మీకు 0.1 వస్తుంది. సారీ 1 వస్తుంది, not 0.1, it's 1. So what is the condition to check that the corresponding matrix is a joint probability matrix? Sum of all the elements, sum of all the elements should be equal to 1. And what is the condition to check that it is P of y by x? ఇక్కడ y by x అంటే కండిషనల్ ప్రాబిలిటీ మ్యాట్రిక్స్. సో డినామినేటర్ లో x ఉంది కాబట్టి sum of all the elements in each row should be equal to 1. అంటే x1 row elements 1 అవ్వాలి. 0.9 plus 0.1. అలానే x2 if you observe 0.8 plus 0.2 that is 1. x3 0.3 plus 0.7 that is 1. So y1, y2, y3 1 అవ్వాల్సిన అవసరం లేదు. That's for P of y by x. So y1 sum should be equal to 1 for P of x by y. Okay. So in P of y by x, sum of all the elements in each row should be equal to 1. And what is the condition for P of x by y? మీరు ఇప్పుడు x by y కూడా క్యాలిక్యులేట్ చేస్తారు. నెక్స్ట్ స్టెప్ అదే. అప్పుడు మీ కండిషన్ ఏంటి తెలియాలి. కండిషన్ ఈజ్ sum of all the elements in each column should be equal to 1. Now, at any cost, first step we completed. That is, we calculated P of x by y. xy, sorry. This is the joint probability matrix. Here we obtained sum of all the elements is 1. అది మీకు 1 రాలేదు అంటే సంథింగ్ మిస్టేక్ యూ డిడ్ హియర్ వైల్ మల్టిప్లయింగ్. సో ఇక్కడ మల్టిప్లై చేసేటప్పుడు P of y by x into P of x అంటే ఫస్ట్ రో ఆఫ్ P of y by x is multiplied with first element of P of x. Second row of P of y by x, you should multiply it with second element of P of x అంటే P of x2, అది 0.25 ఇచ్చారు మనకి. Next, third row of P of y by x, please multiply that with P of x3. So multiplication లో ఏదో మిస్టేక్ చేస్తే you don't get the sum of elements as 1. Otherwise you will get as usual the sum of all the elements should be equal to 1. Then you can say that the obtained matrix is your joint probability matrix. So first step అయిపోయింది. Next, ఇప్పుడు మీరు so whenever you know P of xy, you can easily calculate either the elements of transmitter or receiver. Ante you can calculate the elements of P of X or P of phi. Marginal probabilities easy ga calculate చేసేయచ్చు. So please listen carefully. ఈ స్టెప్ 2 కొంచెం జాగ్రత్తగా వినండి. సో ఇవి తెలిస్తే అన్ని ప్రాబ్లమ్స్ చేసేస్తారు మీరు. So second step is obtain the probabilities P of y1, P of y2 and P of y3 అన్నాం. అంటే ఇక్కడ అన్నోన్ ప్రాబిలిటీస్ అవి P of x1, x2, x3 అవ్వచ్చు, P of y1, y2, y3 కూడా అవ్వచ్చు. So whatever may be at any cost, obtain the unknown probabilities using P of xy. That may be the transmitter messages or receiver messages. So whenever, please listen carefully, whenever a joint probability matrix is given to you or you calculated whatever may be, please observe the sum of all the elements in each column to obtain the receiver elements. అంటే ఇప్పుడు మీకు y1 కావాలి అంటే add all the elements of the first column. If you want y2, add all the elements of second column. If you want y3, add all the elements of third column. Similarly, if you want x1 element at a P of x1, if you want, add all the first row elements. If you want P of x2, add all the elements of second column. And if you want P of x3, add all the elements of third row. This is only by using P of xy, not P of x by y or P of y by x. So wherever a joint probability matrix is known to you, if you want the row elements, if you want the transmitter elements, if you want the first element of transmitter, add the first elements of add all the elements of first row. If you want second element of transmitter, add the second row elements. The third element కావాలి అంటే add the third row elements. మీకు ఇక్కడ you can cross verify. ఇప్పుడు మీకు already మీకు P of x1, x2, x3 తెలుసు కదా. So what is the first element of P of x1? 0.3. ఇప్పుడు మీరు ఫస్ట్ రో యాడ్ చేయండి. ఫస్ట్ రో ఎలిమెంట్స్ ప్లీజ్ యాడ్ 0.27 plus 0.3 not 3 plus 0, that is 0.3. You can obtain P of x1. So similarly, what is P of x2? You are given with 0.25. Please cross verify. So 0 plus 0.2 plus 0.05, that is how much? 0.25. And x3, what is the third element of P of x? Third element at the Cherbiko. So third element it is given as 0.45 which here. So add all the elements of third row. You should get it as 0.45. So if you చూడండి third row 0.135 plus 0.315, how much? 0.45. Okay, that is 0.45. So accordingly, you can cross verify or you can calculate the P of x and P of phi marginal probabilities. So whenever a joint probability matrix is known to you, first thing is please check whether it is a joint probability matrix or not. You can check that by taking the sum of all the elements. That should be equal to 1 రావాలి first condition. If you obtain that, next thing is calculate the unknown probabilities, unknown marginal probabilities, that may be P of x or P of phi. లేదు రెండు కూడా క్యాలిక్యులేట్ చేయొచ్చు. ఎలా చేయొచ్చు? If you want P of x, P of x1 first element, add all the elements in the first row. And if you want P of x2, add all the elements in the second row. If you want P of x3, add all the elements of third row. Similarly, if you want P of y1, ఇక్కడ మీకు ఏం కావాలి? unknown P of y1. Please see here. The probabilities P of y1, P of y2 and P of y3 can be obtained by adding the column entries of P of xy matrix of equation 1. Okay. So P of y1, okay, first column elements please add, that is 0.27 plus 0 plus 0. So P of y1, That is the receiver first element you can obtain by adding the first column elements. That is 0.27 plus 0 plus 0. That is 0.27. Next, how can you obtain the P of y2? For P of y2 allows the add all the elements of second column. Second column elements 8 మనకి 0.03, 0.2 and 0.135. If you take the sum of all the three elements, you can obtain it as 0.365. Okay, and the next third element of the receiver is P of y3. You can obtain this by adding all the third column elements, that is 0, 0.05 plus 0.315, third column. So that is 0.365. So finally you obtain the marginal probability capital P of y consisting of three elements, P of y1, P of y2 and P of y3. What is the matrix size of P of y? 1 by 3 అవ్వాలి general గా. 1 row and 3 columns. 3 columns. అంటే ఇప్పుడు మీరు P of y తో మల్టిప్లై చేస్తే కాలమ్ కి మల్టిప్లై చేయాలి. P of x అంటే రో కి మల్టిప్లై చేస్తారు. అంటే P of y1 is multiplied with first column. P of y2 is multiplied by second column. P of y3 you should multiply with third column. ఇక్కడ మీరు P of x తో మల్టిప్లై చేసేటప్పుడు ఏం చేశారు? P of x1 we multiplied it with first row. P of x2 second row కి మల్టిప్లై చేశారు. P of x3 third row మల్టిప్లై చేశారు. ఓకే, అదే మీరు P of y తో మల్టిప్లై చేయాల్సిన సిచ్యువేషన్ వస్తే ప్లీజ్ మల్టిప్లై P of y1 with the first column. ఫస్ట్ కాలమ్ మొత్తం మల్టిప్లై చేస్తారు. P of y2 second column, P of y3 third column. Okay, so this is how. Now how can you check that the obtained P of y matrix is correct? The P of y1, P of y2, P of y3. How can you say that it is right? The answers are correct. So if you take the sum of the three elements of P of y, that should be equal to 1, as similar to P of x. P of x లో కూడా if you take P of x1 plus P of x2 plus P of x3, sum should be equal to 1. సో అలానే ఇక్కడ P of y చెక్ చేసుకుంటే మీరు sum of all the elements of P of y should be equal to 1. ఓకే, సో మీకు ఇక్కడ ఎలిమెంట్స్ ఆఫ్ P of y ఫస్ట్ ఎలిమెంట్ ఏంటమ్మా 0.27 plus 0.365 plus 0.365, that is 1. Okay, so this is how you need to cross verify your answers. మీకు there is no need okay, there is no need for the examiner to correct your answers. సో మీరే ఇక్కడ డైరెక్ట్ గా క్రాస్ వెరిఫికేషన్ చేసేసుకోవచ్చు మీకు వచ్చిన ఆన్సర్ కరెక్టా తప్ప అన్నది. ఓకే, సో P of xy వెరిఫై చేసుకుంటారు బేస్డ్ ఆన్ జాయింట్ ప్రాబిలిటీ మ్యాట్రిక్స్. యూ కెన్ క్యాలిక్యులేట్ either the elements of P of x or P of y. P of y కావాలి అంటే కాలమ్ ఎలిమెంట్స్ యాడ్ చేస్తే రెస్పెక్టివ్ ఎలిమెంట్ వస్తుంది. Next, now you obtained P of xy and P of y elements కూడా వచ్చేసాయి. P of x elements అంటే జాయింట్ ప్రాబిలిటీ మ్యాట్రిక్స్, 2 మార్జినల్ ప్రాబిలిటీ మ్యాట్రిక్స్, అండ్ ఆల్రెడీ మీకు ఇచ్చిన ఫ్రమ్ ద క్వశ్చన్ you have P of y by x అంటే one of the conditional probability matrix you are having. So next leftover conditional probability matrix is P of x by y. How can you calculate P of x by y? Observe the Bayes theorem equation. This is Bayes theorem equation. Okay, otherwise I can write here. This is Bayes. Okay, this is from the Bayes theorem. Okay, what is the remaining? What is the other conditional probability matrix that you need to calculate? P of x by y calculate here. So if you know P of xy and P of y, how can you calculate P of x by y? P of x by y is equal to P of xy divided by P of y. So whether you multiply or divide, so P of y should be applicable to column element only. Complete column ki first element consider cheskuntaru. So using Bayes theorem, you can calculate P of x by y as P of xy divided by P of y. Okay. Now, what is the third step? Obtain the unknown conditional probability matrix. Here unknown is P of x by y, which you can obtain it as P of, you can ask P of x by y is equal to capital P of, how can you obtain P of x by y? You can obtain it as P of xy divided by P of y. So in P of y, you have three elements, P of y1, P of y2, P of y3. Now, every time P of y1 should be applicable to first column only. అది మీరు మల్టిప్లై చేస్తారా డివిజన్ చేస్తారా అన్నది దట్ డిపెండ్స్ ఆన్ ద బేస్ థీరం ఈక్వేషన్. ఇక్కడ మీరు ఫస్ట్ ఎలిమెంట్ ఏంటమ్మా మనకి P of y1. Every time this P of y1 should be applicable only to the first column. అలానే P of y2. This is only applicable to second column, and P of y3 is only applicable to third column. Similarly, for P of x1 that is applicable to first row, P of x2 applicable to the second row, and P of x3 that is applicable to the third row. Okay, so ఇప్పుడు మీరు అది మల్టిప్లికేషన్ చేస్తామా డివిజన్ చేస్తామా అనేది once again you should go through the Bayes theorem equation. ఇక్కడ మనకి ఏంటి వచ్చింది? P of xy is P of x by y xy divided by P of y అని వస్తుంది మనకి using Bayes theorem. So divided by అన్నారు కాబట్టి this P of y1 first element of P of y, okay, first column please divide with the P of y1. Division అన్నది depends on Bayes theorem. So take the joint probability matrix. ఎందుకని P of xy is P of x by y, sorry, P of x by y is P of xy divided by P of y. So first మీరు P of xy joint probability matrix తీసుకోవాలి. Divide this with P of y. ఇలా డివిజన్ చేసేటప్పుడు here P of first, observe the first column. First column, okay, so our P of y1 is applicable to the, apply this to the first column of P of xy. ఎలా అప్లై చేస్తారు? డివిజన్ అన్నాం కదా మనం. సో P of x by y divided by P of y అంటే 0.27 divided by 0.27. 0 divided by 0.27. Third element of first column is 0. 0 divided by 0.27. అంటే ఫస్ట్ కాలమ్ ఏంటి ఉంటుంది? 0.27 by 0.27 అంటే 1. 100 వస్తుంది మనకి. నెక్స్ట్ సెకండ్ కాలమ్ డివైడ్ విత్ P of y2. అలానే థర్డ్ కాలమ్ డివైడ్ విత్ P of y3 అంటే 0.365. అంటే సెకండ్ కాలమ్ థర్డ్ కాలమ్ కూడా రెండు కూడా P of 0.365 తోటే డివైడ్ చేయాలి. Because P of y2 is equal to P of y3 is equal to 0.365. You can observe the same here. P of xy is equal to P of xy. P of x by y is equal to P of xy divided by P of y. So otherwise, I will write here. It will be more clear. P of xy is equal to P of x comma y divided by P of y. Okay, you can observe this equation. P of x by y is equal to P of x y divided by P of y. This is from the Bayes theorem. Now the first column of P of xy is divided with P of y1. So P of y1 is 0.27. So accordingly we divide it. Next, second column of P of xy is divided with P of y2. That is 0.365. So అందుకని second column second P of y2 to divide చేస్తారు. Next, third column of P of xy is divided with the third element, that is P of y3. Accordingly we will divide. Next, if it is 0.27 divided by 0.27 is 1 and other two are zeros. Next, 0.03 divided by 0.365, 0.8.82 వస్తుంది. Check చేయండి. You can check. చెక్ చేస్తున్నారా? Next, 0.2 divided by 0.365, that is 0.5479. Okay, similarly 0.135 divided by 0.365, that is 0.3698. Okay, third column divided with P of y3. So 0 by 0.365, that is 0 only. So 0.05 divided by 0.365, that is 0.1369. And 0.315 divided by 0.365, that is 0.863. Now finally you obtained P of x by y as P of xy divided by P of y. So while division, divide the first column elements with P of y1, second column elements with P of y2, and third column elements with P of y3. Okay. Now finally you obtained P of x by y. Now how can you check that your answer is correct? M0. How can you verify that P of x by y is the obtained answer is correct? So M0. బాగున్నారా? M0. Okay, please tell me M0, please respond. How can you say that your obtained answer P of x by y is correct? What is a clue to verify? Any one of you? Any one of the student can respond. So not only M0, any one of you. What is the condition to verify? What is the condition to verify that your obtained answer P of x by y is true? Any one of the student? Ma చెప్తారా? Any one of you? L9? L9. Okay, lateral entry 22. Lateral entry 22. Cheppandi ba, any one of you. So I don't call you. So please respond. Then we can close the session. What is the condition to verify that the obtained matrix is P of X by Y? What is the condition for cross verification? See, already I spoke the same point. I have repeated it 4 to 5 times. Why you are not answering? You can speak at least once.
Sum of elements in each column is 1.
It must sum of elements in each column is 1. At the first column elements ఏంటి చెప్పండి?
1 0 0.
So sum is 1. Okay, good. Y2?
0.9999 వచ్చింది.
Okay, approximately to 1. Okay, Y3? Approximately equal to 1. Okay, okay, thank you. So what is the condition to cross verify P of X by Y matrix? Sum of all the elements in each column should be equal to 1. Each column. First column P of Y1, like take all the elements 1 0 0. So similarly P of Y2, take the probability sum of the second column, along the third column. So for cross verification of P of X by Y, sum of elements in each column should be equal to 1. And then what is the condition to cross verify for P of Y by X? Sum of elements in each row should be equal to 1. Okay, so if you know these three, like these 4 to 5 rules while doing this kind of problems, you will feel more easy. Okay, so ఇది తెలియకపోతే మీకు వచ్చిన ఆన్సర్ కరెక్టా తప్ప అన్నది you cannot justify. So finally we obtained 5 different kinds of probability matrices. 2 are the marginal probabilities, 2 conditional probability matrices and joint probability matrix. So 5 probability matrices వచ్చేసాయి. I think now you can solve the corresponding entropies. Okay, entita entropies. So by using P of X and P of Y, you can calculate H of X, H of Y. So using the as usual equation, H of X ki equation ఏంటి? Summation J I equals to 1 to 3 P of Xi log 1 by P of Xi base 2 అని చెప్పాను. So Xi 3 elements are there. So what are the 3 elements? 0.3, 0.25 and 0.45. So already calculate H of Y because you have 3 elements of Y receiver. P of Y1, P of Y2 and P of Y3. Okay, get H of Y. So at least ikkada varaku homework cheskoni randi. So H of X by Y and H of Y by X and I will explain. So I think you can calculate H of X and H of Y because directly the probability values are known to you. Direct P log 1 by P base 2 equation petti represent chesayadame kada. Calculate H of X and H of Y and get me the answers by tomorrow. And conditional entropy and the remaining other problem we can discuss in the next class. Okay. So any doubts in the today's class? So these model problems are very important for your examination. So ee problem 8 marks ki cheyochu. Okay. Any other doubts? So if you have no doubts, you can leave the class. No problem. So any doubts you can ask or else you can leave the class.